Hello everyone, I am Dr. M. Manikam, Assistant Professor, Department of Physics, Dr. SNS Rajalakshmi, College of Arts and Science, Coimbatore. So today in this video, we will discuss about AC circuits with double components, that is resistance and capacitance, that is connected in series. So this is the topic today we will discuss in detail. So let's get started. So this is the circuit diagram for AC circuits, that is the resistance and capacitance that is connected in series. So E is equal to E naught sin omega t is the AC source, and then resistance and capacitance are connected in series. This is the resistance and capacitance connected in series. So in this video we'll going to derive equation for to find out the voltage across the circuit and current through the circuits. These are all the things we'll discuss. How the AC circuit or AC current is flowing through the components, electronic components like resistance and capacitance. So this is the basic equation for the AC circuits that is connected with the resistance and capacitance are connected in series. So here E is equal to E naught e power j omega t. This is the basic voltage, EMF equation for wave equations. First we have to find out the voltage. So we voltage equation, you can the total EMF across the circuit is we have utilized two type of components, that is resistance and capacitance. So E is equal to VR plus VL. So we have to add these two values. Okay, so the total EMF, that is E is equal to VR plus VL. So we have to substitute the value of VR and VL in equation, the above equation, that is where VR is equal to I into R, then VL that is equal to J omega L into I. So this is the voltage drop across the circuit. Then we can write it as E is equal to, we are adding both values, so E is equal to IR plus I divided by j omega c. So we will get I into R plus 1 by j omega c. Here instead of this equation we should substitute the I divided by j omega L. So this is the VC. So finally we'll then this is the equation for voltage. So E is equal to I into R plus 1 divided by j omega c. So this is the voltage equation. Then equation for current, I is equal to E divided by R plus 1 divided by j omega c. So then we can find out the impedance. So I is equal to E divided by Z. So Z is equal to R minus j divided by omega c. So we will get I is equal to E divided by Z. So this is the current equation for this AC circuits with the double components, that is resistance and capacitance. Then we will find out the magnitude of the impedance value. So Z is equal to square root of R square plus 1 divided by omega c whole square. So this is the impedance value. Then again we will find out the Z value, impedance value. So square root of R square plus 1 divided by omega c whole square. Then we will get the I value. So I is equal to, we can substitute the real wave equations here. So I is equal to E naught e power j omega t divided by Z value. So that is square root of R square plus 1 by omega c whole square into e power j theta. So there is a derivation part is involved in this equation to derive this equation. So here theta is equal to e power j theta is there. So theta is equal to tan inverse of 1 divided by omega c into R. So this is the angle equation. And then finally we will find out the current equation. I is equal to I naught sin omega t plus theta. So where I naught is equal to E naught divided by square root of R square plus 1 divided by omega c. So with this equation we can conclude that in RC circuits current leads voltage by an angle theta. So the theta value is tan inverse of 1 divided by omega c into R. So the graph for graphical representation of waveforms, that is current and voltage, E is equal to E naught sin omega is the voltage and current is the dotted lines is the current. I is equal to I naught sin omega t plus theta. So here see the starting point of voltage here starting from 0, but the current value is leads by an angle theta. So the value of theta is um, tan inverse of 1 divided by omega c into R. So this is the conclusion. So thank you for watching this video.